Hello, good morning, everyone. We just want to make sure the audio is clear. There is a question panel on the right side of your screen. If you can please help us just to make sure that the audio is okay. Hello, I don't know if, let's check. Luis Bantroy, if there is any way that you can let us know that the audio is okay, the audio is clear, please let us know on your question panel that's on the right side of your screen. Okay. So let's wait around 2 to 5 minutes just to wait for everyone to join us, and then we can start. Eric Singer, he is with us today to tell us about PCTEL. So let's just wait about 5 minutes, and then we can start with Eric.
Sounds great. I'm ready when you are. And also anyone who is on, I've got the chat box open. So if my audio starts to sound bad or anything, just let me know and I will dial in on the phone as well.
Thank you. Thank you so much, Eric. Okay, hello everyone. Thank you so much for being this morning with us. We're ready to start our PCTEL webinar with Eric Singer. Let us know if the audio quality is okay. If there is a question panel on the right side of your screen, if you can please send us a message just letting us know that the audio is it's good and clear. Thank you, Brian. All right, Derek, I think we're ready to start.
All right, let's go into this. So I know this was labeled a webinar on PCTEL Connected Solutions. I'm going to go into the Connected Solutions, sort of a new name for the antennas group. But I'm also going to go into the scanning receiver products that we have available for public safety. For testing coverage on in the public safety and cellular realms. A lot of buildings have, or a lot of municipalities have brought forward codes that say they need to be able to communicate with fire, police, ambulance, all public safety inside those buildings in order for the building to get commissioned. So we will go into that a little bit later on.
Igualmente.
Little feedback here. Okay. So we'll start with the new public safety radio requirements. We'll move into the antenna solutions that you typically know from PCTEL. Then we'll get into the public safety testing solution and show a little bit more in detail what the grid testing process and requirements are. And the grid test is sort of a more simple version of a traditional DAS walk test, tailor-made for the public safety community. So what are the new needs for public safety antennas? I think that the new radios are really a big deal. You got things from Motorola and Harris, including the Apex 8000, that require a blending of all the P25 bands with some more traditional VHF, UHF bands. So it essentially covers 136 to 174, the UHF band 400 and 500, and into 700, 800, and 900 to get P25 and the LTE public safety bands, all in one antenna, all in one port on those radios. There's also add-ins of different types of radios. We've got, you'll see a lot of police units with a Sierra or a Digi or a Cradle Point unit to get broadband coverage, because police officers are each required to wear a body cam in many cases. You've got the car's dash cameras. You have real-time license plate readers, which have to exchange video data, run it through a system, and then come back with regular ones and zeros, all in real time, constantly reading several license plates. And there are a lot of cities that have sort of smart city initiatives where you have additional networks coming in, and just a whole lot of data that has not been traditional in the public safety realm, that officers and the firefighters and ambulance need to get in real time to make everything safer and faster and save more lives. On top of that, there is the FirstNet system, which was given to AT&T to have a chunk of frequency that will kick anyone off of the cellular network if a first responder phone, any specific FirstNet unit needs that data at that time. It will be a completely clear channel for them in that area. So going into FirstNet, it all really came about from 9/11. I sort of explained the concept of it. Is it just a cellular broadband network that will be first priority to people that need first priority? It's generally in 700 LTE. As I said, AT&T owns and operates it. So what the bonus for them is because they actually had to pay a lot more money than was given to them for the government for the contract of it, is that they get more channel and spectrum during every day-to-day minute until someone needs the FirstNet, and then it will clear the channels. This is a big win for both the government and AT&T. There's a lot of FirstNet small cells that you'll see, as well as other forms of in-building and base station coverage. And as I was saying, to the point of the modems that are in the vehicles, in the meantime, anything that they have that will cover the bands, as far as we're concerned, from the radio and from the antenna's perspective, they can use those systems just for more broadband coverage to get all that real-time data, video and audio being the most comprehensive of that. And I think eventually we'll see some of that moving into 5G, but we are still several years off from that. Here's just a quick look into some of the antenna systems. I know on the cover of the webinar, you were shown this picture right here that shows the police unit from Los Angeles County. We were able to design antennas specifically for them to fit in between these roof rails. It's called the Trooper, and I'll go into that a little bit more. But we also have not only 1, 2 of them, but I think 7 total antennas outside of that on these roofs. And we had to take this roof, we were sent the full roof, and to scan where the best placement of these antennas were and get a full coverage from just this. Beyond that, you can see that we have this antenna here. This is the PCTWSLMR. It stands for PCTEL Wide Spectrum LMR, and that is that single port I was talking about coming off those Motorola and Harris radios, covering pretty much everything that public safety needs on one antenna. We do have a new version coming out. This one has a very solid base, and if you're putting it on an SUV like this and you're going into a low parking garage or something of that nature, or certain chiefs and higher ups in departments will have their home garages. They were knocking these a little bit, and that thing is stronger than an aluminum roof, so it did have some possibility of ripping right out. So what we've done is made this whole base here a spring, a very soft spring, so it can go right on in, hit, be folded, have no problem. And then this here is a very good view of those roof rails I was talking about and what we had to do to fit an antenna in between. That's the Trooper 1 shown there. Right over here is the Trooper 2, which is a bigger unit. It's actually 9-in-1, so it'll have 4 LTE, 4 Wi-Fi, and a GPS or any configuration therein, and still fit in between these roof rails. Oh, I see that my circles have gotten transposed here, but I meant to circle every one of these PCTEL antennas on here, so at least I can count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of these PCTEL antennas. And you see if I scroll over, there's a little link that pops up. There's actually a pretty fun little clip from Jay Leno's garage of them going through with the LA Police Department or LA Sheriff's Department, showing this new vehicle, all that it can do, versus an old vehicle, which actually still had a PCTEL antenna right on there. So it was a pretty fun little advertisement for us that we didn't even mean to make. So with all these new requirements, there often is need for these multi-band fleet-style antennas. We have some shown here that even go, you'll see these red ones on Bank of America ATMs at the airport. You'll see these blue ones on Chase ATMs that are in mostly hospitals that I've seen. Beyond that, you see all of these being used on public safety. And that's in order to get that broadband data combined with their location and time at any given point. Very important to timestamp all those videos. I think we've seen quite a bit in the news over the last several years, camera data where the timing is very important to piece together the whole story. We have them in multiple colors. We see police usually wanting black, but ambulance, even buses, usually wanting white. So we have them in those two, as well as the specialty ones that we're talking about. And it just goes to show our capabilities of making small changes for big products or big projects. So this is the Trooper Lite. This has only got one LTE, plus a couple Wi-Fi's and the GPS. Key is that it's in black and white, and that it's got that between roof rail design where we limited the size of the ground plane below. Has the same insides. You'll see this throughout the Trooper line versus the Coach line. Same insides, but different external view. I think the key for this is if you look at it from the side, it looks a lot like the shark fins that many police agencies were used to seeing, but it provides a little whip to get that wideband coverage that LTE needs. So here's the Coach I was talking about, often designed for buses, hence the name Coach instead of Trooper. It's not necessarily true that it's just for buses, but you'll definitely see a lot of these on fire and ambulance. They don't really care about it fitting in between any particular area. They prefer a little extra ground plane and like the look of this design. So we keep both around, even though the insides are the same as the Trooper. We have several different flavors of this. Again, the same thing. These are generally 5-in-1, can go up to 6-in-1 with an extra Wi-Fi in there. It's going to have 2 LTEs, and by LTE I mean full spectrum, 698 up to 2700, as well as generally 2 Wi-Fis on the sides and a GPS in the middle. We have done it 1, 2, 3 Wi-Fis in there for different radios and modems alike. We also have it in a shorter footprint. We have the same footprint with different styles of antenna in there. I think the key is we've got these platforms and they're very customizable for your customers' needs. And you know, we can change the connectors, the cable lengths, and even do testing at different things if you have a large enough project to warrant something like that. This is a Cloak. This is kind of it's a very cool covert one. It's available in either a magnet base or an adhesive base. Usually you put them towards the back of the roof and then slide the wires underneath. This is shown on its own little ground plane, but this does not require a ground plane. This was originally developed to be inside the dash of a John Deere unit. So it was for agriculture. And all of these antennas, they have a GPS and GLONASS embedded in them, and coming soon for all of them and already out for some of them, it will have GPS L1, GLONASS, BEDO, GPS L2, and GPS L5. So the exactness that it can get down to as far as where you're at with all those satellite constellations and systems comes down to millimeters. So you know exactly where you're at. This is actually more important in agriculture than in anything. So you need to exactly place the seed. You want to place the exact amount of fertilizer, pesticide, even water on an exact seed, and you need to know the real location. Beyond this, they often have ground stations for agriculture to give you even more exact location and have fail-safes. The tractors these days will drive themselves. They just have someone in there for an emergency stop button. And we even had to put in a Wi-Fi antenna broadcasting out from the cellular network so that you could use your iPad or your e-reader right inside those trailers, because there's not much to do. And that's how automated the whole system is. So here is Coach 2. So the next two, we are going into the 9-in-1. So there's a lot of new modems out there that require 2 carriers, both of which need a main antenna and a diversity antenna, so that you can have all sorts of failover, or alternately you can just use multiple radios to get higher and higher speed data. So that's all on the backhaul and uplink to get to the network. and get those speeds, and then we have Wi-Fi to rebroadcast it to or around the car that it's going on, or the vehicle it's going on. And this one already has that L1, L2, L5 possibility in it. So a really high-tech sort of antenna, if there is such a thing, coming out of these Coach 2 and Trooper 2s. But we had to make the cables that go into it thinner because we've got so many different antennas coming in. This stud is actually quite large, but to have 9 cables come in, we had to go down to a higher performance yet thinner cable to get roughly the same amount of loss on all of these units. So here's the Trooper 2, the version that was designed to fit between those roof rails. I think this housing is quite good, and we'll try and get something multiband and low profile with a VHF and UHF antenna in here to avoid the exact problem we were talking about before, where you run into garages or tree branches or whatever and it damages the vehicle. This is low profile and rugged, can take a beating, but spreads the pressure all the way around and is usually lower than a light bar. So just a quick slide. I just wanted to show why we need to combine the data and the communications, talking about the timestamp, talking about the location, and to combine it directly with things like video. If we can show an exact timestamp and have the video running concurrently, sending back to the group, then everything is achieved and we can get it all into one antenna. On the next slide, I'll show a few of the problems that can come with GPS and what we've sort of done about that. We have advanced 4-stage filtering on these things. This is just to show how small an individual GPS unit can be. There are still several forces and several reasons to use an individual GPS instead of combining it for multiband. The largest of which being that you need to have a bunch of antennas on top anyway. If you don't mind putting in a couple of holes for install, it's better to have them a little bit separated. There's co-location of your LTE antennas can interfere in that if you roughly double the frequency of your LTE, you get your higher 700 frequencies in there. You're broadcasting that. Double that is right dead smack on top of the GPS and GLONASS frequencies here. If you look at the difference in separations, I do apologize. Looks like when I published this, it moved a lot of my different red marks on here. Let's just say that there's a sizable gap in not having that filtering versus having this band selection, so that you can get your frequency just on top of this hill, and each one of these is moving down, I believe 10 dB. So that's, it's 10 times less interference. Very important to have this steep cliff coming off. So this is what we have as a little bit of a comparative slide, but without showing anything of our competition. It can be difficult to tune 2 antennas to work as one, and the key is to have that pattern be almost exactly the same, to have the antennas as isolated from each other as possible, so that they function as they would in free space without the other one interfering with it. This just goes to show how similar the 2 antenna elements are. This is a SWR measurement, so it's the return loss, but look that when they're in the same package, and these are 2 different antennas, green and red, they're almost dead on top of each other. So the closer that they can function, the better your MIMO is going to be. And then you look at this pattern and it's just a very nice, almost that pure apple pattern that you're looking for from an antenna. And we show some of the internal functions here. That very thick stud, the nice gripping mechanical bolt, the fact that this GPS unit is seated on a molded unit, so it can't go anywhere, so the bend radii and all of these cables aren't violated. And we see the internals of a lot of our competitors' antennas end up with things like hot glue and fully bent cables without loops and the fact that we have all these traces directly on the board, it's very repeatable, it's very strong, and that they're glued together and soldered together right at the points to act as, you know, one unit in case of, you know, some of these guys are in environments where they get hit, bashed. They're IP67. There's great seals on these things. There's, you know, the mechanicals become just as important as the electricals on antennas like this. And again, I do know, even though I'm not in front of you, that I can get to bore you with me being excited about antennas and you guys sort of just trying to take it in. So bear with me a little bit on the nerdiness I've got. Here's some of the legacy products. Now, no matter how new the antenna world gets and how much we move into the cellular and, you know, LTE, 4G, 5G even, a lot of public safety guys have their own VHF and UHF networks. They have for years. They know how to maintain them. They know that those are great communications methods. They're reliable, and quite frankly, they go further. I mean, just based on a larger wave for lower frequency, if you have VHF antennas, you are going to more reliably be able to talk from one person to another, if on analog or digital voice directly, if nothing else. So forget about any of the broadband stuff. The key is for an officer to be able to contact dispatch no matter where they're at. So we don't see these lines going anywhere. This is the bread and butter. It always has been, and I think it will continue to be. So here's a legacy product, the MLPV, in something that's a little bit newer, LTE. You know, it's hard to say it's new anymore. It's almost legacy in and of itself. But this unit will also be upgraded to go up to 3800, which will be big in the 5G world, even if you're not using 5G, because of that CBRS band, that 3.5 band that we see cellular networks carrying in, and it's a very good fallover for all these public safety units. PCTWSLMR I was talking about. Man, this thing is a beast. This is a perfect antenna. We've sold hundreds of thousands of these as they go directly with the Motorola radio and the Harris radio. So without even selling one under this part number, they get shipped with every unit. It's just amazing that it can cover all of this, how rugged it is, the water ingress protection, and again, you know, we're addressing needs for something newer as far as for the command units. If they go in those garages, that it's literally all spring, and it's a very soft spring constant on there. So it will bend, it can stay bent, it can come out of the garage and pop right back up. The trade-off is that it's a little bit heavier because it's all got to be steel. I'm not going to go too far into these. These are just blades that you can hook onto your docking station with Panasonic Toughbooks and different competitors, although there don't seem to be too many real competitors to the Toughbook. They all have docking stations when you're back at the home office, or if you have something internal to the car. These can connect just to it. These are very inexpensive and can come in large volume. Then we have the more rugged version of this. Again, this is John Deere design, so this one, past shock, vibration, diesel fumes, pesticides, all the different chemicals that are in the air, and extremely difficult tests from John Deere, making it as rugged as you can get for a blade. Base station antennas, key that we're going to see is the BOA Series. This is your most rugged, most reliable, but not your most cost-effective antenna. I know that there are a lot of opportunities within the repeater world, or the P25 base stations around 700, the repeater world, of course, lower, that you need something you can put up there and not worry about for the next 15 years, and this is the antenna for the job. If you need something a little bit more cost-effective and still very rugged, we have the MFB series. This one's been around forever. This one I picked is a 900 megahertz, a little bigger and a little tougher, but you can still see that it's got this full molded base, and it's fully fiberglass up top. It's just not quite as hefty as the BOA series. So both are very reliable and very tough, but this one's going to be more on your cost-effective side. All right, well, before I keep racing through this and get into the public safety testing solution, are there any questions that you guys want to ask about the antennas? The antennas is really where I know more and can nerd out a little bit more, so I just wanted to give a break here and see if anything pops up on the chat, or if you need to unmute and ask any questions.
Thank you so much, Eric. If there is any questions or any project that you got and you want to ask Eric about your project, please send us your questions. And also, just a reminder, this webinar is being recorded. We're going to send this session to your email after we finish. So please send us your information, your questions about your next project, and we'll be happy to help you. Thank you.
All right, well, I could take a chance to breathe. Always an odd environment, just talking straight into your computer monitor. But I'll slow it down a little bit and get into the public safety testing solution. Just a little bit of background. So PCTEL has the two distinct different units that we've had that we gained originally through acquisition. And the one I'm about to go into now is the scanning receiver group. Whoop. Scanning receivers have been traditionally used to test cellular networks by the carriers themselves. They're very high-tech software-defined radios. You see them shown here. We have our MX Flex, our IB Flex, which is what we've been using for 4G. And we've got some older units too, but we've come down to these two. And then this one in the middle is called the HB Flex. It integrates this IB Flex with a down converter, and this one can get up to those millimeter wave bands for 5G. So this is all that very high-tech stuff. All we're going to focus on in this one is this IB Flex, and it's called IB for in-building. It's lightweight. It's got two hot swappable battery packs on the back, so you can just walk around and do your site walk without being weighed down too much. The other units are more for drive testing, and when you've got a vehicle, you're going to carry one of these around. You're going to need a big, strong person to do that. This sort of shows the setup here. This is the Seahawk Touch software. It comes with a tablet. It can show you anything from spectrum analysis to high-end cellular information, sign or BER, all that. And that's really all been rolled into this package that we show here. That's a public safety grid test going on with the IB Flex scanner. You'll see it'll be either in a backpack or in a little side pack, oftentimes to show what it would be like for a first responder to be inside a building as they wear their radios on their belt. Somewhere up here on the chest, you could do the site walk that way, any which way they want you to do. And over here, this is interference hunting. Something to keep in mind, but not, again, more for the carriers to see what is bogging down their system, what is causing problems, and it's got a cool little pistol grip. You aim it around, you can find exactly where the source of interference is. So what's the problem with public safety indoor performance? We've been going on this many years with the same style of thing going on. And I'd say that the problem is newer buildings, newer building materials, and people getting around to the fact that they actually care. There are certain incidents and events that happen that bring new safety requirements to light. I think the one that really rings true for this unfortunate learning experience, as they call it, was the Las Vegas shooting. They had a shooter in a building, a massive building that's, 50 floors or something, and they're trying to have their radio coverage for police, fire, ambulance, you got Clark County, you've got Las Vegas, you've got the state of Nevada, plus you have all the cellular trying to make it into this building with all of these users. And as they tried to determine which room the shots were coming from and how to act, you don't want to shoot across a hall at your own other officer. They tried to communicate on the radios and they could not. So it probably cost a fair number of lives, or at least a large number of injuries, not being able to pinpoint where the room was because they couldn't talk to each other. Some municipalities had come up with different rules. They had leaned on international fire protection, the National Federation, or either way, NFPA and IFC have come up with some loose guidelines that show you how to test your building and make sure that it's correct. And municipalities across the U.S. have picked up and tweaked the versions of what they're going to mandate the buildings have just in order to be commissioned to be allowed to move on. This became particularly important in Las Vegas, as you have casinos and hotels that if they're shut down even for a day will lose millions of dollars. So time became much more important than money, and they needed solutions and fast. So we came up with, I'll talk about the general solution first. And I think that most of you are pretty familiar with public safety DAS systems. You have to get the outdoor coverage pumped inside. So they'll generally put in a BDA and then some sort of distributed antenna system. Usually it's smaller than what you'd need for a cellular DAS system. It's not dealing with quite as much as you're usually just dealing with P25, maybe a DMR network where, let's say there's MGM has their own radio network for their first responders. Before they can get police, fire, and ambulance there, they have security guys that are already on site, and they need those radios to work just as much as police and fire do. So you just have the one bidirectional amplifier and a couple of antennas scattered around, and that should cover entire floors. And let's see how we tackle the solution of, where do you need your DAS systems? Do you need more than what you have? Do you need one at all? So we came up with a solution that utilized some of our existing software. We had a tablet, we had a touch solution, which is our software that goes on this, and we had the in-building scanner that can see all frequencies from 30 all the way up to 6,000 or 6 gigahertz on the one scanner. So it just depends on the antennas that you hook up to it. GPS is integrated but does not really work for you in building, so you'll have to follow some maps. So how do you do that? Skip this, and we're just going to be focusing on this grid-based test mostly. Let's jump right into it. So you can take a map of any building that you have, pre-upload it. You can go back to what I was showing here, and you can upload whatever radio bands that you'll need. Now this is showing something in Maryland, so you see Rockville owned frequencies. Here's the channel, here's the frequency, and then here's what you need to pass, right? There's the, you need this to be at a negative 110 dBm minimum to have a radio conversation. So you set your pass fail at 100 or 95. And then, as required by the NFPA and IFC, they want these things tested in grids. They just want it simple. They want it to be pass or fail. And you are able to upload these maps right into your system. You then pull a grid directly across the screen, and it overlays the equal number of sides. Now, normally, the grid of 20 equal areas is what you'll see for anything under 100,000 feet. And that's an individual floor. And then you put your test points right in the middle of most of these. Now, you can move, let's say the middle is right here in on a pole. You can move these over, do that all ahead of time. You can then list what you need as a, you know, do not test area. Going back to the casino example, you're not going to be able to have any access to the money rooms. There's nobody getting in there. Doesn't matter what you do. So you can say you don't need to test that area. But you also will set critical points, a stairway, elevator. Let's say it's a server room that you need to have passed no matter what. And you set these critical points that these all need to pass. You could say that a floor needs to pass at 95%, and then one of the areas that's not a critical point is allowed to fail, but the rest of them all need to come up green. You walk to the dot, and I've done this myself. It's pretty fun. You just walk to the dot, you tap a button, you wait for enough measurements. Let's say it's 10 seconds, which will depend on the number of frequencies that you're going to test. And this thing will immediately light up green or red. Walk to the next area, do the same. Now, the biggest advantage of this is if you have engineers that have set this whole thing up, you can send any tech, anyone who can read a map and reasonably walk an area, to go do the test instead of needing multiple engineers with multiple tools to try and get the same sorts of information out of it. So here is showing a few of the results that you'll see. You see this area blocked off. This is a do not test area. These are the ones that you've already tested. They came up straight green. I think for our example, we didn't show anything in red. It's unlikely that you'll go through the whole floor and not find anything that's going to be a little below. What we're showing here is something called DAQ, which is an interesting thing for these walks. So not only will you be doing this and have the tablet in hand and have the scanner on your waist, you have to have one of the radios for the system and one guy back at the tower on the radio. And you do a simple, can you hear me now? How do I sound? They do the same thing back. And then you decide on a 1 through 5 system, what is the digital audio quality? Could you hear it? Was it clear? In our system, you can enter that right on in. It does seem kind of arbitrary, but it's really the only way to test uplink and downlink at the same time for what you care about, which is voice. Usually you'll see a 3.0 or a 3.4 being necessary for the DAQ test. So if someone says it passes, they'll usually just plop a 3.4 right in there, and that goes at the same time you hit that test point. And if it's below whatever your minimum is, this thing will turn red immediately. So it's a very nice, easy, clean system. And here's the very best part. It pops up a report that will tell you pass or fail, what percentage. These reports are, a couple pages long, goes through every test point and tells you exactly what that was. So you bring this back to the engineers at the home base, and they now don't have to spend a week putting together this report, sorting through all that data. It just comes out to them, and then they can see, hey, we need to fix a couple of things before we send this report back to the fire chief. Maybe we need to install a new desk, or you say, hey, this is great, everything is passed, and we are going to send this full report exactly to the fire chief, and they can say that it is commissioned and ready to go, and gives those people. So I know this keeps popping up, this AHJ, that's authorities having jurisdiction. So if anyone says AHJ when they're talking about this, they're talking about the fire chief, they're talking about chief of police, whatever it is in that area. If it's DMR, then maybe, like I said, MGM has multiple properties, they've got their own radio band. Maybe it's the head of security for MGM. So you get the full report out, you've done your whole walk, you have a piece of equipment, and let's say you are the VAR, you are doing these walks, you charge X amount, you've used way less manpower, you've taken less time to do it, you've completed the whole thing to satisfaction. you're able to charge what you charge and move on to the next building with minimal cost to yourself and maximum profit margin to yourself. If you're a building owner, now you have this. They are requiring these reports usually once a year. So if you are in the VAR business, then you, by buying one of these scanners, have long-term employment. You get a lot of different projects and engagements, all from the same building. And it's a continued moneymaker for you. If you're a building owner, then you can continue to save money and always have this thing ready to go for whenever you need it. It's software based. Any upgrades or maintenance can be done over the air, and it's just proven to be a very successful solution for us and for a couple of people that we've gone into. And I have a nice case study for you. So this was one of the case studies, sort of kicked it off, as far as Dave Adams, who's our main go-to guy on these, can do those site walks. If we have a webinar that gets a little bit more into detail for people who are a little bit more interested, it'll probably be Dave who does this. So he walked, it was a transit tunnel, and they had, you know, a northbound and a southbound, let's say, tunnel. The first tunnel they did the old way. It took 3 techs and 5 different test devices over 2 shifts. You look at the amount of time that it took, look at the manual reporting and recording time, and the number of admin hours it takes for the report. So that immediately goes from 20 to 0. This, you know, this is the same, the number of the signal measurements, whatever, but the measurements are actually better in tunnel number 2, doing it the new way. 7 man hours instead of 36 man hours on site. That is the biggest key to me, as well as not really requiring any adult supervision. If it went that way, you know, these techs, I'm sure were all highly skilled because this was the first. But moving forward, it could be maybe less knowledgeable guys, guys that are just breaking in and can just do these sidewalks. Didn't have to require any lane closure, because this was actually, I think they did this via driving slowly. So it just had a slow lane, and it picks up those measurements that fast. And the fact that it was only the 2 techs and 1 tool here, I can believe that's 1 tech up at the radio site and only 1 with the test tool. So I think that speaks volumes. Let's see, where am I on time? Oh, I am doing well. Okay, good. So real-time results. The tablet connects to the scanner via Bluetooth. You don't have to have any wires of any kind. Those batteries are hot swappable, as I was saying. So there's 2 batteries. You can pull out 1, put in a charged battery. The 2 batteries are said to give you about 8 hours of time. It probably gives you about 6. It really depends on the number of measurements and what you're doing. But if you have a long site walk, it's really nice to just have extra batteries and swap them in and out without restarting the unit. It weighs about 4 pounds, the IB Flex. It's very easy to carry. It's very easy to have on your hip with the antennas connected, or on your back with the antennas connected. And it comes with the backpack. It comes with the tool preloaded with the software, or, I'm sorry, a tablet preloaded with the tool software. And everything that you could need, including charger cables and data cables if you want to exchange information that way. Although usually you just take a thumb drive connected directly to the scanner, get all that information back to home base when you just hand them, here's the reports. They compiled while we were on the way back. And I think that this is revolutionizing sort of how this was done, instead of an old, here's an analyzer, this is the simple power level of what we get. Now you can say, hey, here's the power level, here's the signal to noise ratio, here's the bit error rate that you can see going on. This is roughly what we would see for, here are the equivalents to that DAQ, and then, hey, here's the DAQ written right on into it. And if you have any questions or comments, here's my contact information, although lucky for you, you've got me for another 10 minutes or so. So you can ask your questions right now. Thank you.
Thank you so much, Eric. I don't know if you can leave your information on screen so everyone can just thank you so much.
No
Well,
problem.
yes, awesome. So everyone, if you want to test or increase your building coverage, please send us an email. We got stock on all this equipment. So please send us an email or send an email to Eric. He'll be happy to answer all of your questions for your next project. We'll be here for a couple of minutes in case that you got any questions about the webinar or any of the products of the webinar. Just a quick reminder, we're going to be sending you the presentation as well as the webinar recording to your email. So you get all of this information on your email in case that you want to review it. If you can send us your questions, we'll be here a couple of minutes. Let's see if we can get any questions. All right, well, I think we're gonna leave your information, Eric, on screen for a couple of minutes. And if you want to add something else, if not, we're gonna end the webinar.
I think I've done plenty of adding here, so I'm okay with it.
All right. Well, thank you so much for your presentation, Eric. It was a really, really good webinar. We're going to upload this information to our website too, in case that you want to review any other webinar on epcom.net. You just need your login so you can review all of this material on our website. Well, thank you so much for being this morning here with us, Eric, and we hope to see you guys on our next webinar. And thank you so much.
Thanks, everyone.
Thank you. Bye-bye.